The moon has been lying to us. For generations, we looked up at the night sky and told ourselves a comforting story about the silver sphere anchoring our orbit. We thought it was the ultimate boring museum piece of the solar system, a perfectly understood fossil, but we were completely wrong. To understand what is actually happening up there, you have to look roughly 384,000 kilometers away from Earth. Here lies our moon. It is a massive natural satellite measuring 3,474 kilometers across, dominating our orbital environment and physically dictating the tides of our oceans. It is the only other celestial body that human beings have ever physically walked upon. We have mapped its countless craters, we have sifted through its gray dust, and we have left our permanent footprints in its ancient soil. We told ourselves that we understood exactly what it was. The baseline assumption of planetary science was incredibly simple. We believed the moon was a geologically dead, completely solid sphere of cooling rock, born from a clean, straightforward planetary collision billions of years ago. We assumed it was just a quiet, fossilized fragment of the early solar system, completely frozen in time and hiding absolutely no deeper secrets. We treated it like a solved puzzle. But here's the catch. When we finally tested that assumption, the moon actively defied the established laws of physics. When the Apollo astronauts finally reached the lunar surface, they did not just plant flags and collect geological samples. They brought highly advanced scientific instruments designed to peer inside the rock. Starting in 1969, the Apollo passive seismic experiment successfully deployed a network of incredibly sensitive seismometers scattered across the lunar surface. Over several years, the network quietly recorded over 1,700 meteoroid impacts and numerous deep moonquakes. But the most terrifying and baffling data did not come from natural cosmic events. It came from us. In November 1969, the Apollo 12 mission finished using its heavy ascent stage. Instead of just letting it drift, NASA intentionally crashed the spent spacecraft directly into the lunar surface. The explicit goal was to send a known, calibrated shockwave through the crust to mathematically measure the interior density. When the heavy hardware slammed into the dust at high speed, the seismometers spiked. On Earth, if a massive object strikes the ground, the resulting seismic energy dissipates very quickly. The vibrations typically fade into complete silence within 1 or 2 minutes. But when the Apollo hardware violently struck the moon, the resulting shockwave did not die down. The moon began to ring like a massive struck bell. The seismic vibrations echoed deep through the interior, bouncing back and forth, continuously triggering the sensitive sensors for an astonishing 55 minutes. The entire celestial body was reverberating with trapped kinetic energy. We had struck our supposedly dead satellite, and it had answered with a prolonged, impossible resonance. To understand why a 3,470-kilometer-wide sphere of rock rings like a bell, you have to understand the sheer violence of its past. On Earth, we have deep oceans of liquid water and a warm, viscous, molten mantle that acts as a massive planetary shock absorber. When violent kinetic energy hits the Earth, the water and the internal heat rapidly dampen the wave, absorbing the destructive energy and quickly silencing the vibration. The moon has no such dampening system. It is bone dry, and its upper layers are completely, brutally cold. The absolute lack of water means there is no physical medium to absorb the shock. For over 4 billion years, the lunar surface has been subjected to a relentless, apocalyptic bombardment of hypervelocity meteorites. Because the moon has no thick atmosphere to burn up incoming debris, every single piece of rock that intersects its orbit slams into the surface at terrifying speed. This continuous cosmic artillery has fractured the lunar crust to an unimaginable degree. The outer 20 kilometers of the moon is not a smooth, solid sheet of rock. It is a shattered, highly porous shell of overlapping craters and deep, chaotic structural cracks. When the kinetic energy from a crashed rocket booster enters this shattered crust, it gets instantly trapped. The seismic waves bounce wildly between the millions of subterranean fractures, reflecting off the dry, shattered rock over and over again without ever losing their energy. The moon is essentially a dry, fractured sponge. endlessly reverberating with the violent ghosts of every impact it suffers. But the extreme fracturing of the outer crust does not explain the entire anomaly. When geophysicists analyze the deepest, lowest frequency resonance signals recorded by the Apollo seismometers, the mathematics refuse to settle. If the moon were truly a simple, uniform rock all the way down to its center, the seismic waves should have decayed in a predictable, linear fashion once they passed the shattered crust. They did not. The vibrations behaved like waves traveling through a deeply complex, organized interior. We assumed the lunar mantle was a boring, homogeneous sphere of cooling rock. We were completely wrong. The problem was the data itself. The analog tapes beamed back in the 1970s were notoriously messy. They were filled with intense electronic interference from the seismometers, wild temperature swings, and the absolute limitations of early recording technology. The true signals from the deep interior were buried in a chaotic blizzard of static. Then modern artificial intelligence stripped away the noise. In 2023 and 2024, a team of researchers led by astronomer Arthur Briaud at the French National Center for Scientific Research published a groundbreaking reanalysis that completely dismantled the old lunar models. They utilized advanced high-precision signal processing algorithms to filter out the pervasive hardware noise inherent in the legacy Apollo data. By applying modern computational power to the 50-year-old waveforms, Briaud and his team successfully isolated the true, subtle seismic vibrations echoing from the absolute center of our satellite. What they uncovered was a complex, multi-layered architecture that had been hiding in the static for over half a century. The reanalysis revealed that the moon does not possess a singular, simple, solidified core. Instead, it is partitioned into distinct, sharply defined layers of varying density. The AI identified deep-seated structural interfaces that acted as mirrors for the seismic waves, reflecting them back up toward the crust in a complex, organized dance of refraction. The researchers also confirmed the existence of a distinct, solid iron inner core measuring roughly 500 kilometers across, surrounded by a fluid outer shell. The moon is not just a fractured sponge, it is a meticulously layered, structured globe. This structural complexity fundamentally breaks the canonical models of how the moon evolved after its birth. If the interior is this highly structured, it absolutely implies that the moon underwent a much more violent, prolonged period of thermal and chemical differentiation than we ever dared to imagine. It was an active, churning world that settled into its current form through a highly sophisticated, multi-stage cooling process involving active mantle overturn. We are now looking at an object that was geologically active and internally complex for significantly longer than our current textbooks allow. But this hidden structural complexity is only half of the mystery. The deeper, vastly more terrifying secret lies in how the moon was physically assembled in the first place. To understand the origin of our satellite, you have to understand the giant impact hypothesis. For over 40 years, this was the absolute, unquestioned consensus of planetary science. The theory argued that roughly 4.5 billion years ago, a rogue Mars-sized planet named Theia violently slammed into the proto-Earth. The massive, catastrophic collision ripped the outer layers off both worlds, ejecting a colossal cloud of molten rock into orbit. Over millions of years, that superheated cloud gathered together, cooling and solidifying into the moon. It was a clean, elegant, and mathematically satisfying origin story. If that 40-year-old theory were true, the chemical composition of the moon should be a clear, distinct blend of Earth material and Theia material. The fingerprint of planetary formation is written in isotopes. These are specific, microscopic variants of elements that carry an unalterable chemical history. Every single body in the solar system, from the smallest drifting asteroid to the massive core of Jupiter, possesses a distinct isotopic signature. It is a cosmic barcode. It permanently tells us exactly where an object was born and what materials it was built from. For 40 years, we were absolutely certain of what the moon's barcode would say. We assumed that the impactor, Theia, was a massive alien visitor from a completely different region of the early solar system. When it violently crashed into the proto-Earth, it should have left a massive chemical footprint. We expected the lunar rocks to be a clear, messy hybrid of two radically different worlds. We told ourselves that the moon was at least 70% alien material. But when planetary scientists finally developed the technology to look closely enough, the canonical theory completely fell apart. In recent years, planetary scientists began utilizing ultra-high precision mass spectrometry to re-examine the original Apollo lunar samples. They specifically looked at the isotopes of oxygen, titanium, and iron. They pushed the analytical machines to their absolute physical limits, measuring the atomic ratios to a level of precision that was completely impossible in the 1970s. The result was not just surprising, it was a total catastrophic violation of the giant impact hypothesis. The isotopic composition of the moon and the Earth were essentially indistinguishable. They were not a messy blend of two different worlds. They were a perfect, identical chemical match. To understand why this is so terrifying for our models, imagine two people from completely different continents being asked to provide a DNA sample. You expect their genetics to be radically different, but the lab results come back, and they are not just similar, they are identical clones. You realize that your entire assumption about them being strangers was completely, fundamentally wrong. That is the exact crisis we now face with the Earth and the Moon. The identical isotopic fingerprints prove that a simple glancing collision between two solid planets could not have created our satellite. If Theia just clipped the Earth and threw a bunch of solid debris into orbit, that debris would have maintained its alien chemical barcode. But the rocks we brought back show zero evidence of a solid alien world. The chemistry is totally, impossibly homogenized. That raised an obvious question. How can two massive, solid planets collide with enough energy to create a moon, yet somehow mix so perfectly that their chemical signatures become identical? The old theory of a clean billiard ball collision is dead. The only physical way to achieve this absolute level of chemical uniformity is if the collision was so unimaginably violent that it completely vaporized both worlds. We are not talking about a rock hitting another rock. We are talking about the total, instant liquidation of two terrestrial planets. Imagine you are floating in the vacuum of space, observing the early solar system roughly 4.5 billion years ago. You see the proto-Earth, a young, molten world. Then, a massive object the size of Mars violently intersects its orbit. The two planets do not just crash, they completely annihilate each other. The sheer kinetic energy of the impact is so immense that the crust and mantle of both worlds are instantaneously flash-boiled. The solid rock turns directly into a superheated, incandescent cloud of gas and liquid, expanding out into a massive spinning structure called a synestia. The solid rock turns directly into a superheated, incandescent cloud of gas and liquid, expanding out into a massive spinning structure called a synestia. The Earth is gone. Theia is gone. In their place is a hellish, rotating centrifuge of liquid rock and vaporized metal, expanding out to occupy the entire orbital space between the two dead worlds. The temperature inside this cloud exceeds 10,000 degrees Celsius. This boiling, rotating torus churns and mixes for decades, acting as a planetary-scale homogenization machine. The alien chemical signature of Theia is completely erased, violently blended into the vaporized remains of the proto-Earth. A vaporized ocean, a spinning torus, a total annihilation. What is truly unsettling about the synestia model is the complete erasure of history. It is deeply disturbing to realize that the ground we walk on and the silver sphere we look up at were born from such absolute destruction. The moon did not simply break off from a surviving Earth. The moon and the Earth condensed together out of the cooling, vaporized ruins of a destroyed system. The satellite we thought was a quiet museum piece is actually the solidified residue of a completely erased reality. What I find most difficult to sit with is not the violence of that event. It is the completeness of the erasure. Two entire planetary worlds cease to exist, and the only surviving record of them is the silver disk we look up at on a clear night. We thought the moon was a simple rock. The chemistry proves it is a tombstone. The synestia model explains the fractured crust and the identical isotopes, but it leaves a massive, glaring void in our understanding of the absolute center of the moon. When that superheated magma ocean finally began to cool, it did not settle evenly. This chaotic cooling process is exactly what created the bizarre, multi-layered internal architecture that the AI-driven seismic reanalysis finally managed to detect. As the vapor condensed into a boiling ocean of magma, the heavier metals sank. The lighter silicates floated to the top, slowly solidifying into the thick, heavily fractured crust that now traps seismic waves and rings like a bell. But the deepest center of the moon, the absolute core of our satellite, remains a frustrating, shadowy void in our data. We simply do not have enough resolution from the 1970s Apollo seismometers to see all the way to the bottom. The old analog tapes can only take our artificial intelligence algorithms so far. We know the distinct mantle layers exist. We know the isotopic barcode perfectly matches the Earth, but we do not know what is buried at the very center of that shattered sponge. Does the moon have a partially liquid outer core churning with radioactive heat? Is there a dense, solid iron seed at the absolute center that somehow survived the vaporization event? Is the physical ghost of Theia still hiding in the deep center, compressed under 3,000 kilometers of rock? To answer these questions, we have to go back. We have spent half a century assuming the moon was a finished chapter in our history books. Now, the international space community realizes we have to completely rewrite it. This is the driving scientific force behind the upcoming Artemis program. When NASA launches its heavy-lift rockets to return humans to the lunar surface, currently targeting a landing near the lunar South Pole in late 2026, the goal is not just to put human boots back in the regolith. The true objective is to establish a permanent, modern scientific foothold. To finally solve the mystery of the interior, planetary scientists are actively developing the Lunar Geophysical Network. This ambitious project will deploy a grid of 4 autonomous, next-generation seismic stations across the near and far sides of the moon. These are not the primitive, noisy analog instruments of the 1970s. They are ultra-sensitive precision tools capable of measuring ground displacements as small as a single nanometer. They will run continuously for a decade, powered by advanced radioisotope thermoelectric generators to survive the brutal minus 130 degrees Celsius temperatures of the 2-week lunar night. They will form a permanent, global listening grid. We are going to listen to the moon again, but this time, we are going to hear the entire echo. If the Lunar Geophysical Network successfully deploys, the data it beams back will finally pierce the core. It will tell us exactly how a vaporized cloud of 2 dead planets condensed into the ringing, layered machine that physically controls our ocean tides. It might even reveal that the core of the moon is fundamentally asymmetrical, a warped, lopsided remnant of a catastrophic collision that nearly destroyed the Earth before it could even begin to harbor life. The data will either confirm our terrifying new models or shatter them entirely. There is a philosophical weight to all of this. The celestial object we have stared at for all of human history, the only other world we have ever physically walked upon, remains a fundamental mystery hiding its true nature in plain sight. We look up at the night sky and tell ourselves a comforting story about our place in the universe. We assume that because we mapped its craters and brought back a few hundred kilograms of rock, we conquered its deepest secrets. We treated the moon like a solved puzzle, a dusty museum piece quietly orbiting our vibrant planet. But the 55-minute seismic echoes, the hidden internal layers, and the perfectly matched isotopes prove that we had missed the truth entirely. The moon is not a quiet dead rock. It is a violent, complex, and deeply scarred survivor. It is a constant, physical reminder that the solar system is not a safe, stable clockwork machine. It is a chaotic, merciless environment where entire planets can be instantly erased and brutally rebuilt from the vaporized ruins. Every time you look up at the silver sphere in the night sky, you are not looking at a simple satellite. You are looking at the tombstone of a destroyed world. Thanks for watching, and I'll see you in the next one.